my name is Vanessa Johnson. Welcome back to this short series on digital cartography, the theory. And today we are going to look at the role of remote sensing in geographic information system, global positioning system, and how it is used in map production, reproduction, and analysis. So it's actually quite extensive, but I have tried to make it quite short so that it is I'll be able to explain it in short. And if you need the notes, you can definitely comment down below and I'll send you the notes through email or something. Okay, so moving on, role of remote sensing in map production, map reproduction, and map analysis. Again, we are talking about digital cartography. Just recapturing a bit from before, digital cartography basically means to digitally make maps using computers or any digital means. Okay, so in that, to be able to make these digital maps, we have something called as remote sensing. Now, before I move forward, let me tell you, I already have a video on what is remote sensing. If you do not know what is remote sensing, you can go ahead and watch that. It will be in the playlist in my section. You can just go there and view it. But I will just explain what is remote sensing in short. Remote sensing is basically getting information about anything that is on the surface of the earth without touching or reaching that place. For example, using with the help of satellites. Okay, if I have a satellite, I can use the satellite to take pictures of various places on the earth. Once I get the pictures back, I can find out exactly what is there on that particular place on the surface of the earth without actually needing to go there. Okay, so that is basically remote sensing, remotely finding out what is there on the surface of the earth. So how does this remote sensing help in map production? So the first point is data acquisition. Remote sensing acquires high resolution images and data over large areas. So it can take pictures, it can get me a lot of information, give me a lot of information about these areas that are on the surface of the earth, right? This data serves as a fundamental input for map production. So whenever I need to make a map, I need to have the data first, right? So this remote sensing is giving me the data. Okay, next thing is the cartographic base layer. So in order to make a map, I need to have some base layers. So these layers are made some basics, or some of these layers are land cover, exactly what is there on the land, the topography of the land, the elevation, is there a depression in the land, is there a lake, is there a river, what exactly is the physical features on the land, and the hydrography. Hydro means water and graphy means visualization or mapping sort of the water. So like, where are the lakes, where are the rivers, stuff like that. Okay, so remote sensing is allowing me to see all of these things without going to that place. So it's giving me a lot of data. It is telling me about the land cover, the topography, and the hydrography. Then we have the third point, updating and maintenance. So I may make a map. Say for example, I made a map in 2020. Okay, I can update and I can maintain that map. I can keep updating it every few months. I can update it every week. I can update it every single day as well. So for example, Google Earth images, you will see that they have images. Some of the images are quite old, some from the late 1900s as well, that you can see on Google Earth. So from that time, they have been updating and maintaining the map till now. So you will see almost each month you can see a change in the earth's surface. You can see the differences. All of that is done through remote sensing. Now, how is remote sensing helping us in map reproduction? So first thing is data replication. I can simply and very easily replicate and distribute the data that I am getting among many people. For example, if I get data from, say for example, Bhuvan is a website that the Indian government has made for mapping, and it is using Indian based satellites. Okay, so if you go through my remote sensing videos, you'll find out the ISRO and various companies or various organizations have founded Bhuvan, and they give us a lot of data. Coming back to data replication, with this data I can share this data with a lot of people, and we can use this data to make maps. Okay, so this data is very easily replicated and distributed, very very easy. Next thing is consistency in reproduction, because remote sensing ensures that there's a consistency in map reproduction, right? It can make multiple copies of the same map, and it can reduce errors and any redundant data. If there is some data that is constantly coming through, it can completely eliminate it. So that means it reduces our errors, it reduces any mistakes that we would be able to make, right? And then the next thing is efficiency. It is very very easy, and also very minimal manual intervention. So without me doing many things, I'll be able to make maps using remote sensing. Next point is map analysis. How are we going to use remote sensing for map analysis? So there is something called as land use and land cover. Exactly how is the land used and what is the land covered with? Okay, this is something that you must ask yourself. That is LULC, that is land use, land cover. How is the land used, and how and with what is the land covered? So the land can be used for agricultural purpose, the land can be used for urban planning, the land can be used for various different purposes. Okay, and what is the land covered with? Is it covered with construction? Is it having a certain type of plant, or whatever it may be? So we can find out how this has changed over time. Next is natural resource management. We have a lot of natural resources. We have vegetables, we have plants, we have water bodies, we have soil. These are all natural resources, and how we manage them is upon us. So it is very easy. Remote sensing makes it very easy for us to be able to manage our natural resources in the given area. Next is disaster management. So remote sensing plays a vital role in disaster management and response. It helps in mapping affected areas. It helps to analyze the damage, assess the damage, how much damage has happened, and support the rescue and relief operations. So it can help in telling us exactly where we need to go, who do we need to help exactly, etc. Then we have environmental monitoring. This I had done in the previous videos as well. Environmental monitoring is basically where parameters such as air and water quality, temperature, pollution levels, all of this can be monitored day in and day out. Almost every minute, every hour, all of this is monitored, and it can be used for climate change studies, etc. Then we have infrastructure planning. In order to build anything, we need to know, we need to analyze, we need a lot of planning that needs to be done. So for this planning, we need good maps, and remote sensing helps us to make good maps with which we can plan roads, we can plan cities, we can plan the basic infrastructure development. So this was the role of remote sensing. Now we will move on to the role of geographic information system. So what is geographic information system? It is an information system that is used to help make digital maps. Okay, so again here for map production we have data integration. when we have a lot of data, remote remote sensing gives us a lot of data. Once we have all of this data, this data needs to be integrated. So this data integration is very easily done using GIS. Okay. The next thing is data editing and visualization. GIS has a lot of softwares, so the softwares makes it very easy to edit, visualize, change the type of map that I want to make. I can add colors, I can make it visually appealing, okay, aesthetically pleasing. Next, we have layering and map composition. So when I am making a digital map, I can very easily layer multiple maps on top of each other. Okay. Then we have cartographic designs. In cartographic designs, it gives us the style of the font style, the symbology, the way that I want to make my map, the way I want to lay it out, all of that enhances the aesthetics. So this is all basically to make it look good, to be make it easy to understand. Okay. Then we have map reproduction. Here we have data sharing and distribution. Again, this is very easy. I can simply share whatever map I have made through email or by any other electronic means using an internet connection. Then we have data replication. I can copy the data from a website and I can make maps. I can easily make multiple copies of the map, right? I can reduce errors in my map. All of this comes under data replication. Then we have version control. In version control, GIS allows version control, ensuring that any updates or changes made to the original map can be tracked and managed systematically. Since these maps are being made using GIS softwares, they will obviously have a control of the version and it will obviously be updated. Okay. Whenever you must have seen Google Maps ask for updation, right? When they are updating, they will have the previous information, but they are getting in new information as well. So because of that, you are getting more information, you're getting an updated version of the maps. Then we have map analysis. Again, spatial analysis, I have explained this multiple times. Spatial analysis means the whatever is on the surface of the earth has to be analyzed, right? So all of that analysis, geographic data is analyzed. Okay. Then geospatial queries. Now geospatial again means the word spatial comes into picture. Geo means earth and spatial means whatever is on the surface of the earth. So GIS basically allows users to execute spatial queries to extract specific information from the map. For example, it can identify all locations within a certain distance from a given point. So for example, you open Google Maps, you go to your particular location, you can see everything around you is already mentioned on the map there. Okay, so this comes under geospatial queries. Then we have pattern detection. In pattern detection, GIS can identify and analyze patterns in spatial data, such as clusters of certain features or hotspots of specific events. So it can find out if there is a particular pattern. When we are doing population studies or settlement studies, there are these patterns that we look for. We look for linear patterns, we'll see star shaped patterns, we'll see trellis type of pattern. So this is a bit advanced, but there is a pattern that is noticed, a star shaped pattern, or you can just find out a little bit more about it later if you want. Okay. Then we have network analysis. GIS can perform network analysis to optimize routing, assess accessibility, and plan transportation networks efficiently. So basically, when you use Google Maps, it tells you the shortest way or the fastest way to reach a particular area. Nowadays they have come up with a method to save fuel. So how are you saving fuel? Because of the particular road that you're going to use, or because of the time that it's going to take you to travel. All of that comes under network analysis. Then we have modeling and simulation. So GIS can be used for modeling and simulation to predict potential scenarios, such as urban growth, flood modeling, or the spread of disease, aiding in decision making and planning. So I can basically make a model and simulate a particular instance. For example, if I'm making a map for Pune city, I can see if it floods, if it rains too much, and if it has to flood, where will the flood waters reach first, where will it be flooded first, where will it not be flooded, and if it is flooded, what areas are more vulnerable to the flooding. So all of these various types of things you can use and do via geographic information system. We will move on to role of global positioning system. Now GPS is there on each and every person's phone. Either it's GPS or GLONASS or some other positioning system, global positioning system, and it is basically helping us to find out the exact location of anything that is there on the surface of the earth. Okay, so GPS, I'll just tell you in short. If you want, I can make another video of how GPS works, but GPS is basically a constellation of 24 satellites. It was started by the US Army, and initially it was only used for the army, and later they have made it available for the public, where you and I are using it today. Okay, so it helps us to find out the position of any particular object or any particular place on the surface of the earth. It gives us geographic coordinates. So you must have seen these latitude and longitude coordinates, and that's what global positioning system does for us. Okay, now in map production, it helps us in data collection. It can tell us exactly the coordinates of whatever precise location that I want. Okay, if I want the coordinates for, say for example, a hill, it'll be able to give that to me. Okay, so it helps, it is very valuable when you are creating the map to know the exact location of the place. Then there is something called as georeferencing. So GPS provides georeferencing information, which just simply makes the map more accurate and the features of the map very accurate. So the scale would be quite accurate. Whatever I am making on the map would be extremely accurate to the actual earth. Okay, it ensures that the features are correctly positioned according to the real world geographic context. So a lot of times what happens is we make a map, but if we are not georeferencing it means giving it a reference according to the exact earth, according to our real earth, we are giving it a reference, we are giving our map a reference. Okay, so that is very, very important. This is done with the help of GPS and GIS. I would like to add that as well. Okay, then accuracy improvement. By using GPS technology, the accuracy of map data can be significantly improved. So basically traditional maps relied on manual measurements, which might not be precise, but GPS and the coordinates that are generated using the GPS are very, very precise. Then we have map reproduction. We have consistency in reproduction. That means whatever data I get using GPS, I will get the same data every time that I ask for the data. For example, if I ask for the position of, say for example, Taj Mahal. Okay, if I say give me the coordinates of Taj Mahal in 2020, it's going to give me the same coordinates. I ask it to give me the coordinates in 2024, in 2026, in 2028. If I ask it to give me the coordinates of the Taj Mahal in 2090, okay, 2090, in the year 2090, it will still be giving me the same coordinates. Why is it doing the same coordinates? Because it is very consistent. Okay, so that's why there is a consistency in reproduction. It is very precise. Okay, next would be data verification. GPS can be employed to verify the accuracy of reproduced maps. So how true is the map, how perfect is the map, can be verified using GPS. Then we have real time updates. So whatever is happening on the surface of the earth in real time can be marked or can be known with the help of GPS. So if you know about the traffic system that we use, the traffic maps that we have, it uses GPS. Since our phones have GPS and our location services are on when we use the maps, it gathers every single phone's location, and that is how it is able to tell us if there is a traffic jam, or if there is no traffic, if there is moderate traffic, if there is high traffic, right? So this is all coming under real time updates. Then we have map analysis, we have data validation. Again, data validation means how true is the data, okay, how perfect the data is, and basically how authentic it is. Okay, next we have spatial queries and analysis. In spatial, I'm sorry, this red dot keeps coming. Okay, spatial queries and analysis is basically when GPS provides precise location data, and it is vital for conducting spatial queries and performing spatial analysis tasks. So I can find out hotspot detection, I can do proximity analysis, density mapping. So exactly how many things, or how many, like how we discussed about traffic data, how many phones or how many people are there in that place, are they moving, are they not moving, according to that I find out my traffic data. So spatial queries and analysis is very similar to that. Then we have route planning and optimization. When we do navigation, it'll tell us exactly which route to plan for, where to navigate from. If there's traffic, it'll reroute for me, it'll tell me don't take this way, take another way that you can reach faster, right? So that is route planning and optimization. Then we have real time tracking. So you and your friends can try this. Nowadays you're able to share your location with somebody. You can share it on Google Maps, you can share it using WhatsApp. So when you share your real time location with somebody, that person is able to see your location at every given moment, at every given minute, where you are moving. So it is not exactly your location, but is the location of your device, and as long as you carry it with you, it is your location, right? So all of this comes under real time tracking because of using GPS. Then we have emergency response and disaster management. GPS is used in emergency response and disaster management, because we can know exactly where the disaster has struck and where the emergency response is needed. So for example, if there's an ambulance and they come to know that there's a landslide, but to find a landslide without GPS would take a very long time. With the help of GPS, they can know the exact coordinates and they can reach there faster and in a more better and safe way for them as well. So emergency response and disaster management is also a place where GPS is used. Okay, so thank you so much. I have tried, this is actually a very long explanation, but I have tried to make it as short as possible for you. If you have any questions, please do let me know, and I hope you have understood and enjoyed today's video. Thank you so much. I will see you in the next one.